Hello, fifth graders and fifth grade families. So we're going to talk about partial quotients today, and partial quotients is very similar to area model as well as very similar to long division. I kind of call it the middle ground. So we start with area model and we kind of make our way into partial quotients, and then our final step will be long division. So what I'm going to do is I'm going to do a partial quotient problem, and I'm also going to show an area model problem right next to it. I'm going to do it with area model so that we can see how very similar the two questions are. So if I were to do, let's say 97 divided by 2, 97 divided by 2, okay, if we had area model, we would draw our area model. Our 2 would go on the outside, we would split it into 2, and our 97 would go on the inside. When we're doing partial quotients, we are going to draw our division symbol. Our 97 will still go on the inside, and our 2 will still go on our outside, or our divisor will go on the outside, the dividend on the inside. So we're going to use the steps that we would use for area model. So we're going to say again, how many times does 2 go into 9? 2 goes into 9 4 times, and we're going to add a 0. So 2 times 40 is 80. Now we're going to do the exact same thing what we would do for area model, because we would say how many times does 2 go into 9? 4 times. We'd add a 0. 2 times 40 is 80. We would subtract it. We would be left with 17, and we would bring it over. We would do the same thing over here. We would subtract it and get 17, except now we're not bringing it over. We're just going to leave it there, okay? And we are going to end up stacking on top, and I'm going to show you what I mean by that. We would say, how many times can 2 go into 1? It can't. How many times can 2 go into 17? Well, 2 can go into 17 8 times, so we're going to bring that up here. 2 times 8 is 16. Subtract it, we're left with 1. The same with over an area model. 2 times what can get you close to 17? 8. 2 times 8 is 16, subtract it, and we're left with 1. So it's the same thing, it's the same steps, except instead of having it pulled out in this area model way, we're having it just in one single vertical line similar to long division. Okay, so we're taking what we know about area model and we're transforming it into partial quotients like I show here. And then we're going to then make that move into the long division next week. So we add up our quotients, our partial quotients, 40 and 8, which is 48, and then we have that remainder of 1, just like we would have done here with our remainder. So let's go ahead then and we'll do another question. So we have 758 divided by 3. So again, we're going to draw our division symbol. We'll put our dividend on the inside, our 3 on the outside, our divisor. So we're going to first start by saying, how many times does 3 go into that 7? So 3 goes into the 7 2 times. We're going to fill in our zeros. 3 times 200 is 600. We are going to subtract it, and we're left with 158. Then we're going to keep going. How many times does 3 go into 1? It can't. How many times does 3 go into 15? It goes in 5 times. We're going to bring that up to that tens because we're in the tens place. Remember, we line all of our digits up. We add a 0. We fill in a 0. 3 times 50 is 150. Subtract it, and we're left with 8. Then we ask ourselves, how many times can 3 go into 8? It can go in 2 times, so we're going to bring that up here, again lining that up. 3 times 2 is 6, subtract it, we're left with 2. So our answer is 200 plus 50 plus 2, which is 252, with a remainder of 2. So again, instead of pulling it apart and using that area model, what we're going to be doing is stacking it on top of each other. Let's do one more example. We're going to do it by a double digit this time. So we're going to have 1,948 divided by 15. We're going to draw our division symbol. We've got 1,948 as a dividend on the inside, 15 on the outside. Again, it looks very similar to long division, right? It's that bridge between area model and long division. So we ask ourselves, how many times does 15 go into 1? It can't. How many times can 15 go into 19? 1 time. Fill in those zeros. 15 times 100 is 1 times 15 is 15. Add 2 zeros. And then we subtract. We're left with 448. Then we say, how many times can 15 go into 4? It can't. Well, how many times can 15 go into 44? Well, let's count by 15s. 15, 30, 45. Okay, so we went over. So it's 15 times 2. Fill in those zeros. 15 times 20. 15 times 2 is 30. Add a 0. Subtract. We're left with 148. Ask ourselves, how many times can 15 go into 1? It can't. 14, it can't. 148. So this is where we have to, we have one or two options. We can either keep counting our 15s here, or give it a good guess of what we think 15 times what would get us close to 148 and do the guess checking. Well, I know 15 times 10 is equal to 150. So let's see what 15 times 9 is. 9 times 5 is 45. Carry the 4. 9 times 1 is 9, plus 4 is 13. So 15 times 9 is 135, and that's as close as we can get. So 15 times 9. 15 times 9 is 135, so I'm going to subtract 135. And I'm left with 13. 15 can't go into 13, that's my remainder. It's less than my divisor, so I know I'm good. And then I add up what I have left. 100 plus 20 plus 9 is 129, with a remainder of 13. So again, we're just constantly asking ourselves, how many times can our divisor go into the first number or the second number? We make sure we are lining it up exactly how we would line it up for area model. And then we add our zeros in. Okay, and then we, so again, it's that divide, multiply, and subtract. Okay, we are going to be, use this as help for our partial quotients work, and then we will, on Monday, we'll start working through long division. Have a great night. Please let me know if you have any questions.